People often come to me and say, "Professor Feynman, I don't understand quantum mechanics." I smile because that means they're honest. You see, if someone tells you they do understand quantum physics, they're either lying or they don't know what they're talking about. Quantum mechanics is not mysterious because it's complicated. It's mysterious because nature doesn't care about your common sense. We are used to a world where things are either here or there, moving or not moving, on or off. But at the quantum level, the universe laughs at these ideas. An electron can go through two holes at the same time. A particle can behave like a wave until you look at it, and then it suddenly decides to behave like a particle again. And don't ask how it decides. It just does. Now here's the uncomfortable part. Quantum physics works perfectly. Every experiment agrees with it. Every calculation checks out. The math predicts reality with absurd accuracy, and yet nobody knows why it works. That's the real shock. Nature is not strange because it's unknowable. Nature is strange because it refuses to explain itself in human language. And today, I'm not going to simplify quantum physics for you. I'm going to show you why it cannot be made simple, and why that's the most honest explanation you'll ever hear. Why quantum physics refuses to make sense. People want quantum mechanics to behave nicely. They want it to sit still, follow rules, and explain itself politely like classical physics did. Newton's laws were comforting. You push something, it moves. You stop pushing, it stops. You can point at a thing and say, there it is. Quantum physics doesn't do that. And that's not because physicists failed. It's because nature never promised to be understandable. Let me start by removing a very dangerous idea from your head, the idea that physics is about understanding the world. Physics is about predicting what the world will do. Understanding is something we humans desperately want afterward. Quantum mechanics predicts outcomes better than any theory ever invented, better than gravity, better than electricity, better than anything else we have. And yet it makes no sense. That alone should scare you a little. The lie you were taught about reality. From the moment you were born, you were trained to believe that objects have properties. A ball has a position. A car has a speed. A coin is either heads or tails. That belief works very well until you look closely. In the quantum world, a particle does not have a definite position unless you measure it. It does not have a definite speed unless you force it to choose one. And it is not secretly hiding these values somewhere, waiting for you to discover them. That's the part people hate. They want the electron to be polite. They want it to say, I was always here, you just didn't look. But the electron refuses. It behaves as if the act of measurement creates the reality, not reveals it. That is not philosophy, that is experiment. The two-slit disaster. If you want to see where classical thinking dies, you don't need a big laboratory. You just need two holes in a wall. Fire bullets at a wall with two slits, and you get two piles behind it. Fire water, and you get waves. So far, everything behaves. Now fire electrons, single electrons, one at a time. Each electron hits the screen like a particle, a single dot. But when you wait long enough, those dots form a wave pattern. That means each electron somehow went through both slits at once. Now here's where people lose their sanity. If you put a detector to check which slit the electron went through, the wave pattern disappears. The electron suddenly behaves like a particle again. The electron changes its behavior based on whether you are watching. Not because it's shy, not because it's intelligent, but because reality at that scale does not exist independently of observation. That sentence should make you uncomfortable. Good, it should, but surely it has to be somewhere. That's the cry of desperation. People say, fine, maybe we don't know where it is, but surely the electron knows. No, that idea was tested brutally, and it failed. Experiments show that the electron does not carry hidden instructions saying, if measured, go here. If it did, the statistics would look different. They don't. Nature is not hiding the answer. There is no answer until the question is asked. This is not mysticism. This is mathematics agreeing with experiment. Probability is not ignorant. In classical physics, probability means you're ignorant. If I flip a coin, I say it's 50-50 because I don't know all the forces involved. If I did, I could predict the outcome. Quantum probability is different. Even with perfect knowledge, you can only predict probabilities. The universe itself does not know which outcome will happen next. That's the scandal. The universe rolls dice. Einstein hated that idea. He said, God does not play dice. And nature replied, watch me. Why this isn't just small stuff? People try to escape by saying, this only applies to tiny particles. Wrong. Lasers work because of quantum mechanics. Computers exist because of it. Your body chemistry depends on it. The stability of matter depends on it. The only reason the world looks classical is because quantum effects cancel out in large numbers. Reality is quantum. Your intuition is the illusion. Stop asking the wrong question. The most common mistake people make is asking, but how can it be like that? That's the wrong question. The correct question is, what happens if I do this? Physics answers that question perfectly. When you demand a picture, when you demand a story that fits your everyday experience, you're asking for something nature refuses to give. Quantum mechanics does not describe what is happening. It describes what you will observe if you try. And that difference matters. Why I refuse to explain quantum mechanics. People say, Professor Feynman, can you explain quantum physics simply? No. Anyone who claims they can is selling comfort, not truth. What I can do is show you how to think without lying to yourself, how to accept that the universe does not owe you familiarity, how to work with rules that feel insane but produce perfect answers. The moment you stop demanding intuition, quantum mechanics becomes usable, not comfortable, not familiar, but honest. The real shock. The real shock is not that particles behave strangely. The real shock is this. The universe is under no obligation to match the way your brain evolved to think. Your brain evolved to throw spears, avoid predators, and find food, not to understand reality at its deepest level. Quantum mechanics exposes that limitation mercilessly. And that's not a failure of science. That's its greatest success. Why trying to imagine quantum physics ruins it? People keep trying to see quantum mechanics. That's the trouble. They want pictures, little balls, tiny waves, arrows, paths, diagrams that behave nicely in their heads. They want the electron to be either a thing or a motion, a particle or a wave. Pick one. Nature refuse. And the faster you try to imagine it, the faster you get lost. The trap of pictures. Let me tell you something dangerous. Pictures are lies. They're useful lies, but lies nonetheless. When we draw atoms like miniature solar systems, we know it's wrong, but it helps beginners feel comfortable. When we draw waves on a graph, we pretend the wave is a thing in space. It isn't. When we draw particles as dots, we pretend they have sharp edges. They don't. Quantum mechanics does not live in pictures. It lives in numbers, and those numbers do not describe objects. They describe possibilities. That's a hard pill to swallow. Waves that aren't really waves. People hear wave and immediately think of water. That's a mistake. A quantum wave is not made of anything. It doesn't slosh, it doesn't push, it doesn't ripple through space the way water does. It doesn't even exist in ordinary space the way you imagine it. The wave is a mathematical function. It tells you the probability of finding something somewhere if you look. That's it. The wave does not say, the electron is here. It says, if you measure, here's how likely you are to find it. That distinction matters more than people realize. The moment you measure, everything changes. Before measurement, the wave spreads out. After measurement, it collapses. That word collapse makes people nervous. They think something dramatic happens in space, like the wave shrinks or snaps or folds. No. What collapses is your description. Before measurement, you are forced to describe reality in terms of probabilities. After measurement, you are allowed to use certainty for that moment only. Then the wave spreads again. Reality is not changing. Your information is. But what is the electron really doing? That question is poison. The moment you ask it, you've already lost. Because quantum mechanics does not answer questions about what things are doing. It answers questions about what you will observe. If you insist on asking what the electron is really doing when nobody looks, you are asking physics to become philosophy. Physics refuses the language problem. Our language evolved to describe chairs, rocks, and falling apples. Quantum mechanics laughs at this language. Words like location, speed, trajectory, object, motion, they all break down at the quantum level. They don't apply cleanly. They overlap. They contradict each other. When people say quantum physics is weird, what they really mean is our language is inadequate. Nature is doing something perfectly consistent. We're the ones struggling to talk about it. The particle that isn't a thing. Let's talk about particles. A particle is supposed to be small, localized, and countable. You imagine it like a tiny grain of sand. Electrons refuse to behave like that. Sometimes they appear sharply localized. Sometimes they smear out over space. Sometimes they interfere with themselves. Sometimes they tunnel through barriers. They don't have enough energy to cross. No classical object does that. So calling an electron a particle is already misleading. But calling it a wave is just as bad. The electron is neither. It is something for which we have no everyday concept. Why duality is a cheat? People say, wave, particle duality. That phrase makes it sound like we solved the problem. We didn't. Wave-particle duality is not an explanation. It's a confession. It's us saying, sometimes this description works, sometimes another description works. Don't ask why. And that's not laziness, that's honesty. Stop demanding consistency where it doesn't exist. You want the electron to behave consistently across all experiments. Nature says, I'll give you consistency where it matters. The predictions are consistent. The outcomes are consistent. The statistics are consistent. The pictures are not, and they never will be. Why mathematics succeeds where intuition fails? Here's the miracle. Even though quantum mechanics is conceptually impossible to visualize, the math works flawlessly. You follow the rules. You calculate the probabilities. You run the experiment. You get exactly what the equations predicted. Every time. That's not coincidence. That's reality telling you that intuition is optional. The most dangerous mistake, the biggest mistake beginners make, is thinking confusion means failure. Confusion means you're paying attention. If quantum mechanics feels obvious to you, you're misunderstanding it. If it feels uncomfortable, slippery, and slightly insulting to your intelligence, good. You're on the right track. The goal is not comfort. The goal is accuracy. Why I don't trust simple explanations. Whenever someone tells you they can explain quantum physics without equations, be suspicious. They're probably giving you metaphors. And metaphors always break. Quantum mechanics is not mysterious because it's hidden. It's mysterious because it's exact. Exact answers, exact predictions, exact agreement with experiment, and zero obligation to make sense to you. The real lesson, quantum mechanics teaches you humility. It teaches you that reality is not built for human intuition. It teaches you that demanding pictures is a form of arrogance. It teaches you that the universe doesn't care whether you feel satisfied. What matters is what happens. And quantum mechanics tells you that with terrifying precision. The universe does not know the answer until it happens. People hate randomness. They really do. They'll accept mystery, complexity, even confusion, but not randomness. Randomness feels like failure, like ignorance, like we gave up too early. So when quantum mechanics tells us that the universe itself behaves probabilistically, people immediately look for a way out. Hidden variables, deeper laws, secret mechanisms, anything but dice. The comfort of determinism. Classical physics was comforting. If you knew the position and velocity of every particle in the universe at one moment, you could at least in principle predict the entire future. That idea made people feel safe. It made the universe feel mechanical, predictable, lawful in a very human way. We like that. It made ignorance feel temporary. Quantum mechanics destroys that comfort completely. The uncertainty principle is not about clumsiness. Most people misunderstand uncertainty. They think it means we're clumsy observers. That measuring position messes up momentum, like trying to weigh a soap bubble with a hammer. That's wrong. The uncertainty principle is not about measurement limitations. It's about how nature is built. A particle does not have a precise position and a precise momentum at the same time. Not because we can't measure them, but because those quantities do not simultaneously exist. That's a very different statement. Reality is not waiting behind the curtain. People imagine reality like a stage play behind a curtain. They think when we measure, we simply peek inside. No, measurement is not peeking. Measurement is participating. Before measurement, the system is described by probabilities. After measurement, one outcome becomes real, not revealed, created. And once that happens, the universe moves on, leaving no record of what might have been. The death of determinism. Here's the hard truth. Even if you knew everything there is to know about a quantum system, you still could not predict exactly what will happen next. Not because you lack information, but because there is no fact of the matter yet. Nature does not know the outcome until it occurs. That statement terrifies people. Einstein's Laststand. Einstein spent the later part of his life fighting this idea. He believed the universe had to be deterministic. That randomness was a temporary embarrassment, a sign that quantum mechanics was incomplete. He was wrong. Not foolish, not careless, just wrong. And experiments proved it. Bell's quiet explosion. John Bell did something devastating. He asked a simple question. If quantum randomness is fake, if outcomes are secretly predetermined, then measurements performed far apart should obey certain statistical limits. Quantum mechanics predicts violations of those limits. Experiments tested it. Nature violated them. Cleanly, repeatedly, without apology, no hidden instructions, no secret variables, no deeper deterministic layer. The universe is genuinely indeterminate. Randomness is not chaos. People confuse randomness with disorder. Quantum randomness is not chaotic. It is structured. It obeys precise mathematical rules. The probabilities are exact. The distributions are stable. The averages behave beautifully. What's random is which outcome you get, not how often. Nature is disciplined about its unpredictability. Stop looking for the movie reel. People want the universe to be like a movie reel, every frame already there, just waiting to be played. Quantum mechanics says there is no reel. Only the current frame exists. The next one is not written yet. That doesn't make the universe broken. It makes it alive. Why this is not philosophy? People often say, this sounds philosophical. It's not. These ideas don't come from armchairs. They come from laboratories, from data, from numbers that refuse to fit deterministic models. You can dislike the conclusion, but you can't escape the evidence. Probability is the final answer. In quantum mechanics, probability is not a placeholder for ignorance. It is the answer. And that is the most radical idea science has ever accepted. The illusion of control. Human beings love control. We build tools, machines, systems that obey us. Determinism makes us feel like the universe is one big machine we might someday master. Quantum mechanics humbles that idea. You can control the setup. You can control the preparation. You can control the measurement. You cannot control the outcome. And that's not a flaw. That's reality. Why this doesn't make science weak? Some people think randomness makes science less powerful. The opposite is true. Quantum mechanics is powerful because it embraces uncertainty honestly instead of hiding it behind false certainty. Science doesn't promise comfort. It promises accuracy. And quantum mechanics keeps that promise better than anything else we have. The real shock, revisited, the real shock is not that the universe is random. The real shock is that we expected it not to be. We assumed reality had to behave like our ideas. It doesn't, and that's fine. What quantum mechanics teaches you about thinking. Quantum mechanics teaches you how to live without false certainty, how to accept limits without despair, how to work with probabilities instead of demanding guarantees. It teaches intellectual courage, and that lesson applies far beyond physics. What quantum physics does not mean, and why that matters. By now, you may feel uneasy. Good. Quantum mechanics is not supposed to make you feel enlightened. It's supposed to make you careful, especially about what you claim to know. And that brings me to the most abused part of quantum physics, meaning the dangerous leap from physics to fantasy. Whenever people don't understand something, they decorate it. They add mystery. They add spirituality. They add intention, consciousness, cosmic purpose. Quantum mechanics has suffered this fate more than any other theory. People say things like, reality is created by the mind. Consciousness collapses the wave function. You create the universe by observing it. That's nonsense. Entertaining nonsense, but nonsense nonetheless. Observation is not awareness. In quantum mechanics, observation does not mean a human watching with curiosity and intent. It means interaction, a detector clicking, a plate darkening, an atom exchanging energy. The universe does not wait for a human mind to show up and approve reality. It's been doing quantum mechanics for billions of years, long before brains existed. Consciousness is not a magic wand. There is no evidence, none, that consciousness plays a special role in quantum physics. The wave function collapses when a system interacts with another system in a way that produces a definite outcome. That's it. No thoughts required. No awareness needed. No cosmic observer whispering instructions. Dragging consciousness into quantum mechanics is not deep. It's lazy. Why people want quantum physics to be mystical? Because mystery feels meaningful. Randomness feels cold. Probability feels impersonal. Indifference feels uncomfortable. So people replace honesty with poetry. But science is not poetry. Science is the discipline of not lying to yourself. Quantum mechanics does not say anything is possible. This is another popular misunderstanding. Quantum mechanics does not say that anything can happen. It says only certain things can happen, and with very specific probabilities. You cannot will an electron to ignore the rules. You cannot think your way past conservation laws. You cannot manifest outcomes forbidden by the equations. Quantum mechanics is not permissive. It is extremely strict. Why this is still beautiful? People think stripping away mysticism makes the universe dull. I think the opposite. A universe that doesn't care what you want, but still behaves with stunning mathematical precision that's magnificent. A universe that produces structure, chemistry, life, and consciousness out of probabilistic rules that's not empty. That's astonishing. What quantum mechanics really tells you? Quantum mechanics tells you this. Reality is not obligated to make sense to you. Your intuitions are local, not universal. Prediction matters more than explanation. Uncertainty is not ignorance, it's fundamental. Meaning is something you add, not something physics provides. And that's okay. The mistake of asking for comfort. People often ask science for comfort. That's not its job. Science gives you truth carefully, reluctantly, and always subject to revision. If you want comfort, look elsewhere. If you want honesty, stay here. Why I still love physics. Despite all this, or because of it, I love physics. Because it teaches humility without humiliation. Because it rewards curiosity without promising closure. Because it allows you to say, I don't know, and keep going. Quantum mechanics doesn't tell you how to live, but it teaches you how to think. The greatest irony of quantum mechanics is this. The more precisely we can predict outcomes, the less we can describe what is really happening. And yet, everything works. The lasers fire. The transistors switch. The universe holds together. Reality doesn't need your understanding to function. It never did. So if you ask me, do you understand quantum mechanics? My answer is simple. I know how to use it. I know how to calculate with it. I know what questions it answers and which ones it refuses. And that's enough. Because the purpose of physics is not to satisfy your intuition. It's to tell you without flinching how the universe behaves. Even when that answer feels strange. Especially then. Quantum mechanics is not a puzzle waiting to be solved. It is a fact waiting to be accepted. And once you stop demanding it make sense, you finally begin to understand it.